Okay. So hi everyone, I'm Christina. I'm excited to be here and talk to you today about how you can get started in malware analysis without a disassembler. So like many, my path through cybersecurity has been winding. I came to malware analysis exactly the opposite way that I'm going to recommend in this talk. And the idea for this talk came from realizing that my answer to the question, how did you become a malware analyst, was not particularly helpful to most people. So my college background was in electrical and computer engineering. I graduated knowing how to read some assembly, how to program in C, and OS internals. And I was fortunate enough to have mentors that guided me into reverse engineering and eventually malware analysis. As you can tell, I like sharing knowledge and making these skills that seem challenging more accessible. And today we're going to talk about how you can leverage what you already know to expand into malware. So the agenda is pretty straightforward. We'll talk about why not start with reverse engineering, where you should start instead, and then some specific tools and malware examples with those tools. So when many people hear malware analysis, they think reverse engineering. And so the common recommendation is this list of skills, each of which could be a semester long. And for a long time, reverse engineering was the main tool that was used to analyze malware. But reverse engineering is really time consuming. It requires several layers of deep technical knowledge, and adversaries are always trying to make it harder. This was an area that was ripe for problem solving and automation, and defenders need to move fast to understand the capabilities of adversaries attacking them. Luckily, some awesome people have created open source tools or provided a free version of their product that can greatly reduce the time and the need for reading code and putting it back together step by step. And with such a long list of things to learn before you get to the fun stuff, no wonder people think it's not for them. So the overlap of malware analysis and reverse engineering is not a circle. Malware analysis is one tool. It might be the most conclusive, but it is also the most time consuming. So if reverse engineering is the most conclusive way to do malware analysis, why not start there? And the main reason is that it's not always needed. The goals that you have with the malware analysis you're doing might vary, and the time you have to have actionable results can vary. If you can quickly identify the malware family that you're looking at, you can give an assessment of its capabilities, the goals of the adversary behind it, much faster than reverse engineering all that code. If you need to look for activity across your entire network, a quick list of IOCs might be much more useful to you. And sometimes these things do need reverse engineering, but not necessarily all the time. Even a malware analyst that can reverse engineer is probably not going to start by opening a disassembler either. Sandboxes, config extractors, and a variety of other static tools can extract file metadata as well as look for capabilities. The caveat is that it's important to cite what you've used to make your assessment and understand the limitations of the tools you're using. These aren't a silver bullet by any means, but they can get you pretty far down the path of what you're looking for. Even if you do know how to reverse engineer, you need to understand what you're looking for, what goals you're trying to achieve. The focus of a lot of reverse engineering learning paths is compiled code. There's a lot of malware out there these days that is a scripting language. And additionally, reverse engineering might not be the fastest way to get the answers. So knowing which tools are out there, how to use them efficiently, is just as important. So to kind of back up the point that it's not all compiled code with data, this is a list of Red Canary's top 10 threats and malware the programming language associated with that threat. So not every threat is necessarily a malware family, but those are some of the languages used by those threats. And half of these threats are using non-compiled languages. So where should you start instead? Everyone is going to come into this with a different set of skills. These are some core high-level skills that I think are important for doing malware analysis. I'm not sure if the difference in color is clear, but the top two are in black, and those are ones that I think are a little more common if you're already working in the cybersecurity space. The ones in gray, you may have come across in your work, or you may not have yet. So we'll talk a little bit more in depth about those. So the first is tool proficiency. So I've mentioned this a few times. There's great tools out there. We'll talk about a few specific ones a little later. But gaining expertise in the tools that you're using, what information they will give you, what information they won't, times that they will break or maybe give you incorrect results is really important. Reverse engineering is often used to validate the findings of these tools or dig in if there's discrepancies found. It's also important to know which information from the tool you can take as with high confidence, like this tool said this, I really believe that, or this tool said this, so I'm gonna run like 5 more tools and see what they say, because sometimes it has false positives or sometimes it's wrong. So programming languages, there are, like I mentioned, a lot of the threats use scripting languages, especially your initial downloaders or droppers. So picking up just one to start with, and you don't have to become a professional programmer in this language. Some basic syntax, understanding maybe some of the unique features or gotchas about the language can help, since malware authors, kind of abuse those things to obfuscate their code. That can really go a long way in being able to quickly look at a JavaScript and, say, make some judgment call about what it's doing or where you're going to look for deobfuscation. So file properties, this might not be something that you've paid a lot of attention to. It doesn't really change the way that the file executes or shows up in EDR telemetry. But malware families sometimes have patterns with signers or file metadata that you can use to start kind of grouping things or getting a sense of what malware family it might be. The executable files are organized into sections that get loaded into memory. So high entropy or odd section names can also be a point of interest in malware analysis, or give you a hint that I know that malware commonly uses this section name, and that's not used in normal software. It's at least bad, likely, can be a big help. And if you go on to learn reverse engineering, it's really, the file formats are foundational to understanding how malware is obfuscating itself and performing anti-analysis. So I have a couple examples of building on knowledge that you might already have. So if you already are doing a lot with EDR telemetry, the next thing you might look at is sandbox data. Sandbox results look a lot like EDR telemetry. Here's the processes that ran, here's the files that were dropped, that sort of thing. From there, you can kind of dig into maybe some of the output that's less familiar to you. Like, next, you might run some open source malware, some C2 frameworks where you can read the code and then see how does that show up in the sandbox to kind of get an understanding of the tool. You can maybe write some of your own code in that new language you learned and see what does or doesn't execute. And that can then be expanded into writing Yara rules that look for certain behaviors that you're writing with your code, or identifying trademarks of the malware. The next example is maybe you have experience in clustering activity based on adversary TTPs. So you might decide that you're gonna dive into the PE file format, understand the different parts of it, which parts can be leveraged for starting to cluster malware families or find overlaps, understanding some of the similarity of algorithms out there like rich header hashes or import hashes to find similarities. Additionally, if you do a lot with maybe network infrastructure, A lot of sandboxes will provide PCAPs, so you can start looking at, are there protocols that this malware family uses? I know they go out to this infrastructure, but what does that look like more on the endpoint? Like, how are they actually making those network calls? Okay, so as predicted, I'm running massively ahead of time. Okay, so the last section that we're going to talk about is some tools and some malware analysis examples. All right. So there are a ton of tools out there. These are just a few to get started. Along with the foundational knowledge that we talked about, it's important to know what tools you have at your disposal. The Flare VM has every tool imaginable on it, but two that are worth calling out specifically are Yara and CyberChef. Yara is a pattern matching tool. We'll talk about it in a minute. So GitHub might seem like a strange resource for malware analysis, but in fact, adversaries also are perfectly willing to use code that's already been written for them. And sometimes you can find overlaps in unique strings. And so if you run strings on the file you have, maybe there's some specific error codes or things that just look unique. GitHub might be a good first place to start looking, because if you can find the code, if you find code that looks similar, you can then read the code and compare that to what you're seeing in your EDR telemetry or your malware sandbox, and get a sense of, have this level of confidence that these are the same things. And now you don't have to reverse engineer, you just get to read their source code. Malware databases are also a great resource. Both VirusTotal and MalwareBazaar provide basic file information. VirusTotal will let you pivot on certain fields, like the imp hash, like I mentioned earlier. It provides behavioral information. Both have malware family and Yara rule hits when they're available. MalwareBazaar is great in that it will have links to a variety of sandbox reports, so you can even compare sandbox to sandbox. Some might be better at certain aspects of anti-analysis, and others, might have, they might have slightly different information. So that can be helpful to corroborate your understanding, and this way you don't have to put the hash into every sandbox known to man to see if they happen to have it. So speaking of sandboxes, you can look up hashes directly. Looking through, like I mentioned, sandbox data is a lot like EDR telemetry, and in some cases, if the malware made network calls, they even have PCAP available. So you can use Wireshark to start investigating PCAP information. And sandboxes are also a great way to build your own skill set in terms of, you can see what the sandbox has provided. Can you independently verify that? Why does it think that it's this specific malware family? What were the things that rule maybe was written to trigger on? With sandboxes, it's also really important to understand their limitations. So a malware tries to do sandbox detection. They get really creative with this. I think it was last year, there was some malware that had evolved their mouse tracking analysis to identify sandboxes. So sandboxes are pretty smart. They do a lot to get around things, but the adversaries are always trying to do one better. So it's important to have that in the back of your mind. Is there something going on that the malware is stopping the sandbox from doing something? If you pulled the sample off of VirusTotal or MalwareBazaar and it required command line arguments to run, it's not going to run fully. So that is important to be aware of, and that's something where reverse engineering could be, and if that's something you're growing into, like that could be a good first step. Like, does this thing use command line arguments? Can I get that little piece and get this thing to run? And the other thing with sandboxes is if it is like a full remote access Trojan and it's taking commands through the network, you're probably not going to get the adversary to start sending commands in the 20 minutes that your sandbox is running. So you'll get initial activity, but you won't get full capabilities that might happen later on as an adversary sends commands. So I've mentioned Yara a few times. Yara is a pattern matching tool. You can write rules pretty much for anything you want. You can write these based on strings. So yes, you can write rules with hex, but you don't have to. Like if you can also do signer information. So there's a lot of flexibility with Yara. There's a lot of open source rules. Every January, social media does 100 days of Yara. So even if you don't write 100 Yara rules, you can see what other people are writing, see what people are targeting for their rule evolution. So that's a really, really helpful tool. There's this is just a few static analysis tools. The screenshot is from Kappa. It's not, don't try to read it. Detect It Easy is always a good first go-to. It gives you high-level file information, like detects the compiler, that sort of stuff. PE Studio and CFF Explorer will give you similar information to what you get on VirusTotal, but maybe you don't want to upload your file to VirusTotal, so you can run those yourself. Floss and String Sifter are two tools that run on top of strings. So if you run strings, it'll give you any ASCII sequence greater than, I think, 4 characters. So there's a lot of garbage in it. There's an anti-analysis technique called stack strings, where the malware will put each byte onto the string one at a time, and so there's not a string in memory for you to find. Floss does additional analysis to find those sorts of strings. It also will print out ASCII and wide character strings for you. So that is a lot faster than running strings a couple times. And String Sifter is really cool. It uses machine learning to try to bubble up the most interesting strings to the top. I like running both because sometimes there is value in seeing which strings were next to each other in memory. It can make a little more sense. But especially if it's Go or something like that, like you want to see the unique strings first. And then Kappa, like I mentioned, this is a screenshot from Kappa. It gives you capability analysis based on, and it will link those to attack and the malware behavior catalog techniques. So you can kind of quickly read the techniques, and if they don't make sense, you can always reference attack or the malware behavior catalog to get a more in-depth visibility. Its rules are also open source, so you can see the rules that it matched on and go look up exactly what those are looking for. So that's another opportunity for learning. What does it mean that a specific binary is doing this sort of anti-analysis? Like, what is it that they were looking for in the code? So CyberChef, I think, is probably the one that people are most familiar with across the board if you haven't done malware analysis before. But one really cool thing about CyberChef with malware specific is you can start creating recipes to deobfuscate malware families. So you can do a lot more than just a quick base64 decode. And I included a recipe resource on GitHub. Similar to Yara, there's a lot of recipes out there, and they're really helpful to learn from and to see how someone else has approached detecting bad behavior in code. Assembly line is probably my favorite tool because it combines a lot of tools together. So it is open source, and it's from the Canadian Centre for Cybersecurity. It is organized by plugins or what they call services. So for almost any static tool imaginable, there's a service for it. And if there isn't, you could write your own. It does a great job deobfuscating JavaScript. It recursively will analyze the files. So as it finds a new file type, it will see if it can extract additional files and perform type-specific analysis as it goes. And it can be configured to connect to Cape for dynamic analysis. So this is something you would have to install yourself. It runs in Docker, but it is similar to Flare VM. It's a great one-stop source for a ton of tools without having to Google and find everything one by one. Two of the biggest features, I think, are its Yara rule matching service and its config extractors. You can point it to any Git repo that you're interested in, so you can keep your rules in Git all nice and organized, and just point it at that and it'll run those so you can quickly get family identification or configuration extraction if possible. And so not quite a resource or tool, but in terms of scripting languages, something that can be useful is the IDE for the language, or VS Code with a syntax highlighting plugin. And this can be a good way to start building your own reverse engineering methodology. So without having to know assembly or computer architecture, you can maybe take a JavaScript file that's obfuscated, and you can start kind of building that muscle memory of, well, this is the thing I want to know. Let me run the debugger to here, refactor my code now that I got some runtime variables. And that iterative process that's going to be very similar if you do go on to reverse engineer. And that way, when you go to traditional reverse engineering, you're just doing that same thing, but in a new language. So they have 3 malware case studies. Let me grab water. Okay, so again, don't read it. The point is that it's messy. So you come across node.exe executing this mess, this unreadable mess. So you put it in assembly line, and it says, hey, this is obfuscated with this obfuscator that we can identify. That's probably bad. We'll highlight it in red for you. And here are some heuristic tags that we've come up with. One thing that's good to point out here, if you can see it, oh, sorry, I don't know if you can, is that in terms of knowing what your tools give you and what their limitations are, for the domains, it thinks that process.pid is a domain. And it is probably not, but unfortunately, there's not really any way for assembly line to know if someone has decided to register process PID or if PID is even a top-level domain. So that's, you can't take things and just throw them in a report. You kind of have to think about them a little bit. Yeah. I didn't do a screenshot of it because it was just kind of messy, but the code before that was in that big chunk that we saw looked, it was running some deobfuscation routine. Assembly line was able to deobfuscate it, and it has a file viewer that you can view its deobfuscated code. So you could go into assembly line and see the deobfuscated code. Part of it was these hosts and cloud IPs, and so that's much easier to read than trying to figure out the algorithm yourself. Similarly, there was another obfuscation string that was doing something with regadd, and after deobfuscation, there's still some variables, but it's a lot more clear that it is setting up persistence. So, did we find some IOCs if that was our goal? Yes, we did. Do we know what it does? Some of what it does, at least. And if we need more info, we now have a script that is way easier to read. And so maybe with our newfound JavaScripting skills, we can finish whatever obfuscation might be left and have a really detailed understanding of what that malware has done. So you have analyzed this malware. So some more JavaScript. This one has an MD5. If you can see it there, the line numbers are in the hundreds. Everything before this screenshot were those comments that were useless. And so we can see if that hash happens to be in Malware Bazaar, and it is. There were a few different sandbox results, but we'll focus on Joe's sandbox. It had some signatures that identified some capabilities. It even helpfully told us that its COM object activity might be dropping a second stage, so we don't have to kind of infer that ourselves. It helpfully tells us. And we can easily go to Joe's sandbox and look at the full report. This is just a subset of it, but in there we have some domains and IPs, as well as the URLs that it was calling out to. So we were kind of quickly able to triage and understand some information about that. We put it in assembly line. It gives us some signatures of things it's doing, some suspicious processes, but unfortunately the deobfuscation is not as awesome as last time. It's still not very readable. So isn't there this like cool new thing that can just read the code and do all the malware analysis for me? Like why do I need to learn this at all? I put this in Gemini. I figured if it's good enough for VirusTotal, it's good enough for me. And it gave me a really long readout. It was able to identify that there was a massive useless comment block. I identified functions involved with obfuscation and how they related. It ID'd likely algorithms that it was using, RC4 and base64. It also found variables associated with PowerShell calls and the use of COM, which is similar to what we saw from Joe's sandbox. It identified some dead code meant to throw analysis off, which I'd seen in assembly line and thought, I don't think this function's ever going to run, but wasn't sure. And it provided a deobfuscated URL in command line that matched what we saw in Joe's sandbox. So it can be, that said, like any of the tools we've talked about, you have to verify what it is giving you. It can be helpful to assist your analysis efforts. So it thinks that there's some RC4 and base64. I can now go and confirm that. It has identified that there's PowerShell. I can go confirm that. So it can be a good starting point. But so is it useful? Definitely. Should you just take this and send it? No. So for this case study, we found our IOCs. We found a good bit of the capability. We're not quite sure what the PowerShell does, but maybe we can pull that out now from the sandbox and do some dig into there. And if we need more info, at least we can now focus on the remaining questions. Okay, so the last case study is not JavaScript. There's a MD5, and this file is in VirusTotal. We can see that one of the tags, the VirusTotal tags, is assembly. That doesn't mean assembly code. It generally refers to a .NET assembly, so that's an indicator it's .NET. A couple of the AV engines have a MSIL label on it, so that's also a .NET indicator. And one of them thinks it's async rat. There's also 10 comments in the community tab. Those might be links to sandbox runs, links to reporting referencing this file, or it could be nothing useful. And if you have a VirusTotal account, you might get more information like malware configs, open source Yara, Suricata, and Sigma rules. So since this one's compiled, we can throw it into Detect It Easy. Detect It Easy identifies it as being Visual Basic. It has labeled it Venom Rat, which is different than the information we got from VirusTotal. And it has some heuristics identifying possible encrypted payloads and anti-analysis. So if we do some Googling, we find that Venom Rat and Async Rat share some code similarities, and the Async Rat is on GitHub. So we use an additional tool. We'll just keep going down our static tool list. This is Kappa. It's identified a bunch of attack techniques. And an important thing to recognize about Kappa is that it identifies behaviors. It can't tell you why it's doing that. So is there software that looks for a debugger and is perfectly legit? Yes. But this combination of things, like virtual and sandbox evasion, may be less likely to be legit. So it's important to kind of understand the behaviors, but also, kind of apply some judgment of how much you know, right? So you can say it checks for debugging. Maybe that's malicious, maybe it's not. But in this case, we have a lot more techniques. So let's throw it in a sandbox. This one happens to be VMware. It matches some Yara rules that they have, and unfortunately it's down at the bottom. It also extracts malware, a malware configuration that it identifies as async rat. So if a config is extracted, it's generally a pretty safe bet that that is the malware family. But since async rat is open source, maybe they left that part alone. It also provides a list of IOCs. So back to Googling async rat and venom rat, it turns out that a lot of these, because it's open source, there's a lot of overlapping .NET rats out there, and someone has helpfully created a Yara rule that encompasses all of them. So we can run Yara. The -s flag here prints out the things in the rule that matched. So that can help us, in this case it's hex, so it's not that helpful, but you can see, do I think that the things it matched on are maybe a really loose rule? Or do these things seem really specific? It can kind of give you a sense of trust in, your how good the rule is. But in this case, it identifies it as async rat. So given the combination of factors, the malware config being pulled out, and the fact that venom rat, async rat tend to have a lot of code overlaps, it's pretty safe to say that this is most likely async rat. So we can pull out dnspy, which is a .NET decompiler, and luckily this file is not obfuscated at all. So this looks a lot like .NET code that you might write yourself, and it's pretty easy to read. And so from here, we can search GitHub, we can look for async rat specifically, and start comparing and contrasting the code and seeing, these functions are matching up and class names are matching up pretty precisely. So that gives us even more confidence. So we have our IOCs quite a while ago. We got high-level behavioral information from Kappa. We got even more details from VMware, and we don't even have to read the decompiled code. We can go read the source code to say what it does, or maybe even the README. And yeah, if we need more information, we can read the code. So the fine print. Yes, there will be malware that these tools don't work on. If you are interested in diving down the reverse engineering rabbit hole, learn C, learn assembly, learn computer architecture, pick your favorite disassembler. It's also important to know when to grab the disassembler, assuming you even have time. So if there's anti-analysis that you think is in your way, if you're looking to do attribution based on software design or algorithms used, you might have to do reverse engineering. Or you need to understand the command and control at a really deep level. Like, those are things you're probably going to have to grab a disassembler for. If you're interested in learning this, ost.fyi is a great resource, open security training. I'm biased, I've done content for them, but it's free assembly, architecture, and reverse engineering classes. So yes, but as I think you saw, you can get really far without needing to open a disassembler. So if you are interested in malware analysis, There's a lot you can do before you hit the wall of I can't go further. And malware analysis is always done generally for a purpose. So you have a certain amount of time and you have certain goals that you're trying to achieve. So knowing how to do that in the fastest way possible is part of the trade. So bringing it all together, you can start analyzing malware before you learn reverse engineering. If you're already working in cybersecurity, you can build out from what you know. So you can keep digging a little further towards malware analysis without diving into the deep end. And that can keep being useful to what you're currently doing and not feel like a side quest. You can develop a reverse engineering methodology on an easier language so that repetition and critical thinking is similar no matter what language it's in. So obfuscation, how do I get around that? How do I find runtime information, compare static versus dynamic analysis tools? That all applies even to scripting languages. And it's also important to cite your analysis sources because the tools can make mistakes. So instead of writing a report that says, this is async rat, I know it, I'm sure, it's good to give your evidence. I see it's async rat because I found these code overlaps. This tool said this. This YAR rule is what I use to say that this matches. That way someone else reading that can understand, oh, well, I happen to know that rule can misfire, So are there any questions? Yes.
Is obfuscation, is that different from encryption?
Yeah, the question was, is obfuscation different from encryption? I would say that it is a superset. So encryption obfuscates the information, but you can obfuscate without encrypting. So I wouldn't call base 64 encrypting, but it does obfuscate. And you could write a custom obfuscator that's not actually using encryption. I don't think I'd call an XOR encryption. But I don't know, maybe it is. Yes?
What is an example of anti-analysis that could prevent analysis?
So an example of anti-analysis, so specifically with sandboxes, malware does a lot of checks, like how big is the disk space? Do I have a mouse attached? There's infinite things that you can look for that a real environment would have that might not be true in a sandbox, because a sandbox, you're trying to do it quick and cheap, be able to revert it and keep running. So yeah, the sky's the limit. Yes?
If you were to hire a malware analyst, what things would make them stand out to you?
If I was... That's really tough.
Sorry.
I feel like I'm in the interview now. I think curiosity. I think that plays a big role in malware analysis. Like, why is it doing this thing? But also and this would be very hard to figure out in an interview, but you have to know like what scope you're looking for, when to stop, like how to budget your time, because you could spend forever going down some rabbit holes. So when to pull out of the rabbit hole, when to kind of take the higher look. Yeah.
Are there any new AI tools that you like to use, or anything coming out?
I haven't gotten to use a lot of them yet. I think Binary Ninja has like an AI tool built in, but I haven't used it. But the concept is really cool that you could. I think one challenge with AI tools in reverse engineering, though, is that a lot of them require you to send the data out to do the analysis. And so if you have malware samples that you don't, like the one I showed, I got that off of VirusTotal, so it wasn't proprietary to a company, where it wasn't something where you're worried, like, is the actor going to notice that I submitted their malware somewhere? So that can be a challenge if you don't feel comfortable submitting the malware to a third party.
What is something like the scripts and stuff, maybe ones that automate some of that? I guess the tool you said does that similar, right?
Yeah, most of them will, especially if you run them on the models that are meant for code analysis. It's similar to, like, you can think of malware as software, right? So malware developers are essentially software engineers. Their code just does bad things. So anything that, can be used for code development or understanding legacy code, that sort of thing, is also going to do a good job on malware. Yes.
Say, does memory analysis play a factor into, your day-to-day, especially when you're dealing with something that's like, living off the land binary or dealing with delta data structures, things like that?
Yeah, definitely. So in this case, if you're trying not to get into manual reverse engineering, I would say the sandbox is probably the best tool for memory analysis, because it will run it will load it into memory, and then, for example, the sandboxes I showed will scan the memory with Yara, so you can and look for malware configs. But if you're doing manual analysis, then yeah, you'd put in a debugger, get it to load, and then run your tools. Yes.
So if I were looking into like a vertical supply chain, like Apple, where there's like open source repositories available, but there's also closed source where I'm not necessarily able to vet exactly what the provider is giving me, is there a like malware analysis tool or resource that you could recommend, like to be able to use to be able to just essentially analyze, does this look close enough to what is known to be a good operating system, or a whole operating system?
Off the top of my head, I'm kind of blanking. I think, yeah, especially if you're talking Apple specifically, you'd want I would say if there's a sandbox that runs Apple OS, then that might be a good route to go. But it can, determining malicious, like if it's not lighting up all the antivirus or on the the NSRL list, it can get really tricky, because it's amazing. You look at software and you're like, this is probably benign, but why is it doing this weird thing? So the gray area is tricky. Yes.
What are like the ideal operational outcomes you're trying to achieve when you do malware analysis?
So for us, I would say there's two focuses. One is improving our detection engineering. So we're looking, are there things that this file could have done, and we would see that in endpoint telemetry? How can we detect that? And then the other is, can we identify what family this might be from and have a better understanding of what adversaries are doing? Yes?
Sorry, David, one more question. Do you guys do a lot of stuff with like novel malware, like stuff that APTs are regularly pushing out, on a yearly basis, or does it really just sort of depend on who you engage with?
It really depends on, we see a pretty wide variety of everything. So, yeah, it depends. Yeah.
Could you recommend a macOS malware analysis tool?
I haven't done a lot with macOS, so I'll catch me.
Silver Sparrow.
Oh, yeah. I should say, yeah, my coworker has done a lot with macOS. Yeah, catch me later and I'll ask him for you. Any other questions? Feel free to come up and ask me questions anytime if there's something you didn't want to shout out into the audience. So thank you all for coming.